Good evening, everyone. We are in the week 3 problem solving session of the NPTEL course, Network Analysis. And week 3 is about solution to linear differential equation with different excitation. So let me share my screen. Are you able to see my screen?
Yes, I'm visible.
Okay. So this week we'll be talking about solution to linear differential equation. So it is linear, but the order can be anything like first order, second order, or nth order. So initially we'll start with the first order. But before that, I have a question. Like, why do you need to learn solution to linear differential equation? Like, how that is relevant to this course? Like, where it is being used? Anyone? Like, where we'll be using this theory? Like, in this course at least. Any idea? Any guess? Okay, let me just give you a hint. So, what did we learn in the last 2 weeks, week 1 and week 2?
So we have seen mesh analysis, node analysis, KVL, KCL,
Okay.
and initial conditions,
Yes.
and
Yes.
storage and power delivery. Yes, all these things.
Yes, yes. So we have learned these things. So now, if we write last week we have studied about IV characteristics. There we have
Yes,
obtained some time relationship, right? Like
yes,
as a function of time, we have written the expression. So if you see any RLC network, in order to solve it, first we'll write the equation KCL or KVL. So after
yes,
writing
yes.
that expressions, IV characteristics, say I want to find inductor current or I want to find capacitor voltage expression. So it will be a differential equation. So now this differential equation could be first order or second order or third order, depending upon how many components are there, how many inductor capacitors are there in the circuit. So now, if it's a first order, we all have studied how to solve it. We solve it by integrating it, but that is not always the possible. Like if you see in an exam, you cannot always do integration because sometimes it takes time. So today we are going to discuss if I have a differential equation, how to solve it quickly rather than solving it by integration. We will develop the theory. So while developing the theory, we'll integrate the differential equation and get the solution. Now we generalize that solution for any nth order differential equation so that we need not integrate for each and every question. Rather, we'll write the generalized solution and then we'll find the constants. So first thing is why we need to solve the linear differential equation, because any RLC network is linear. From any RLC network, we'll get a linear differential equation. Okay. So now the first thing is, how are we going to solve this? That is the thing, because it is in a differential equation form. Now I want the time domain expression. So basically we are looking for time domain expression. So this week we are going to learn about how to get the time domain expression. If I have given a differential equation, linear differential equation, the order would be anything, first order or second order, or depending upon the circuit complexity. So we'll see a couple of problems today. But before going to that, there is another thing. So it is always not mandatory to solve in one particular way. So today we are going to learn by solving the differential equation and like I would say time domain analysis. But there is also something called Laplace transform, which is basically invented by Laplace to solve the linear differential equation in much simpler way. So what we are going to learn today, it is the classical old approach, before Laplace has invented the Laplace transform. Later, he has invented Laplace transform, using which we can directly solve the differential equation very easily. So once we learn the Laplace transform, you'll realize that uh, it is much simpler to use Laplace transform to solve any differential equation. Then the first question will be, then why are we learning this method? Why are we not learning that method directly? So when it comes to learning, it's not always that you will learn the easiest method. You should learn all the methods, and depending upon the application, you will apply whichever is comfortable to you. But it's not that I will learn only one method. You should have the knowledge of all the methods, the original method as well as the easiest method, so you can solve the same problem in both the methods. It's about learning different ways of approach to solve the problem, rather than just sticking to one easier way. It is like okay that you solve a differential equation using Laplace, but you should also know the conventional classical approach of solving the linear differential equation, which we'll be learning today, and Laplace transform will come in the future. So that's why we usually start with the old approach, and with time we learn the easier approach, because as the circuit becomes complicated, it will be very difficult to solve using the method that we are learning today. So we go for an easier approach. But in the exam, you have the freedom to choose any one of the approach, and Laplace, of course, will be easier. We'll make less mistakes. So before we start the actual concept today, any doubts till this point?
No, sir.
Okay. So first we'll start with the first order, then we will develop the concept and generalize it for nth order, and then we'll see. So the first will be first order differential equation. And this course is very fundamental. It will be used in all other uh, electrical courses that we'll be learning in the future. So these are very fundamental courses, and that's why these are very crucial. If we are not clear about these concepts, they are going to affect us in the future. So these fundamental courses are very important, because these concepts are like the fundamental building blocks for other courses and other additional complicated concepts. So we will take one first order differential equation, dy by dt plus ay is equals to x of t. So when we have any differential equation of this format, the first thing that you have to do is multiply by e to the power at. Why? Because there is this a here, so that's why we'll multiply by e to the power at on both the sides. So why we will do this? So that we can simplify it. So let us write the expression dy by dt into e to the power at plus ay into e to the power at is equals to x of t into e to the power at. So now this left hand side can be simplified something like this, d by dt of y into e to the power at. So now if you expand this, you will get the above expression. So that's why we are multiplying by e to the power at. So now this is equals to x of t into e to the power at. So now let us take the dt on the other side. So we have d of y into e to the power at is equals to x of t into e to the power at dt. So now let us apply integrals on both the sides, integration here, integration here. So now what we can write is, I can write it as y into e to the power at equals to some constant a, because when we are integrating, there will be some constant like a generalized solution, plus this integral x of t e to the power at dt. So now if we write the final expression by multiplying e to the power minus at on both the sides, we'll get the final expression something like this. Y of t is equals to a into e to the power minus at plus e to the power minus at integral x of t e to the power at dt. Uh, till this point, is it clear or any queries?
Yes, yes, sir.
Clear, right? So this is the solution that we are getting for the first order. But before we generalize, we have to understand two things. One, we have two terms here, right? So this term is called the natural response. And this term is called forced response. Why? Because the natural response is dependent on the initial condition. So this is dependent on the initial condition. Okay. And this term forced response is dependent upon the input. Because if the input is not there, then this term vanishes. So that's why it is forced, because some input is forcing this response. Because if the input is vanished, then this term does not exist. So that's why this is called forced response, because some input is forcing this response. It is not happening by itself. But whereas the natural response, it is happening by itself. It is not dependent on the input. So that's why it is called natural response. It is happening like naturally, and it is dependent on the initial condition. Now let us try to expand this integral x of t e to the power at dt. Okay. So integral e to the power at x of t dt. So now if we do this integration by parts, and let us, so this we can consider it as u, this we can consider it as v. So first I'll integrate u. So I'll get in e to the power at by a into x of t minus integral of x dash of t into e to the power at by a dt. So now again, if I do the same for the this portion, like if I apply the same integration by parts, what I'll be getting is, first I have 1 by a e to the power at x of t. Now again, if I do the same, I'll have 1 by a square e to the power at x dash of t, again plus integral x double dash of t e to the power at by a square dt. So integration by parts is something like, if we have two functions, you will use this formula to do. Now, because we have exponential term, it will be like an infinite series. So basically, if we expand it, what we'll be getting is, and this is not that much like crucial for this week. This is just the derivation behind the concept that we are learning. So even if you are not that much clear about it, it is okay, but it is just a basic math integration by parts. So you can give it a try. So I'm just directly writing the terms, but once you write, you'll like feel confident. So now if I write the infinite series, I'll have this expression 1 by a e to the power at x of t minus 1 by a square e to the power at x dash of t plus 1 by a cube e to the power at x double dash of t. So when I say x dash, it is the first derivative, x double dash means second derivative, and up to so on. So this is my e to the power at x of t dt. So this is the e to the power at x of t dt. But what is my forced response? E to the power minus at into integral of x of t at. So I have to multiply this by e to the power minus at, right? So now my forced response is what? E to the power minus at integral e to the power at x of t dt. So I have to multiply by e to the power minus at, and 1 by a square, I'll call it some constant. So my solution will become some k naught into x plus k1 into x dot. So it's the first derivative, plus k2 into x double dot, plus up to so on infinite. So is this clear, this part? I have just applied integration by parts, and I have got one infinite series. Now I have just
Yes, yes.
generalized it. Any queries?
No, no, no.
Okay. So now let us write the entire expression. So first term is a into e to the power minus at, and the second term is this k naught into x plus x dash, all these terms. So now the final solution Okay. So what is the solution? The solution is y of t is equals to, I'll write in two terms so that we'll know a into e to the power minus at plus the other solution is k naught x plus k1 x dot plus k2 x double dot plus up to so on. This is the oral expression. This is the oral solution. So now if you see, we have generalized it. So the same thing can be extended to like a higher order system also. But before we do that, so this is the solution for the differential equation. So let us also write the differential equation. So for this given differential equation, say this is our differential equation. This is our differential equation. Then this is the solution. Like we can directly write. First we'll write the solution and then we'll start calculating the A, calculating the K naught, K1, K2, etc. So first we have to write the solution, generalized solution, any given problem. First we'll write the solution, then we'll start solving for the coefficients. But there is an exception here. What is that exception? Say my x of t is equals to e to the power minus 80. Then what happens? K naught x will be k naught into e to the power minus 80. K1 x dash will also have e to the power minus 80. X double dot also will have e to the power minus 80. And those terms will not end. So it's an infinite series. So only when x of t is e to the power minus 80, this generalized solution is not valid. So what happens if my x of t is e to the power minus 80? So let us uh, think about it. So there is only one exception that you have to keep in mind. So this is exception. So what happens in this exception? So in this exception, it is like when x of t is e to the power minus 80, you cannot write this generalized solution and it is not valid only in this case. So then what to do? Still this is valid because still now here we have not generalized anything. So let us use this equation and then see what happens. So let us put e to the power minus 80. In this, if you put e to the power minus 80, then what happens? The integral, the second term. Anyone? E to the power minus 80 into e to the power minus 80 into e to the power 80 dt, right? Agree? So this and this will get cancelled. Integral will be t. Agree?
Yes, yes, yes.
Yes. So now,
Integral of one is t. Yeah.
yes. So now integral will be some t and say
Into some.
yes, e to the power minus 80 into
Into.
integral dt, right? So e to the power minus 80 into integral dt. So integral dt is basically t. We can generalize by putting some constant. Say some constant b we can put. So this will be bt into e to the power minus 80. Some generalized because we are generalizing it. So now what happens? My y of t is a plus bt
A into e power yes, a
e to
plus
the
b
power
t into
minus
e power
80.
minus a two.
Yes. So this is the only exception that you have to remember when the input is e to the power minus 80. This is the exception because you cannot directly use. So this thing only when the question falls under this case, you have to be a little bit careful. Clear or any queries until this point?
No, no, no. No.
No. Okay. So now let us get back to this. So first methods, steps to follow, steps to solve a linear differential equation. So I'm mentioning so that you can follow this. Steps to solve linear differential equation. It is also phrased as LDE. So I'm directly writing LDE. So the first step will be to write the generalized solution. Okay. First you have to, for a given differential equation, first you have to write the right the generalized solution. So first step is to write the generalized solution. Okay, once we have written the generalized solution, then we will solve for the equation. So again, we have two parts here, right? One is the natural response, the other one is the forced response. So for calculating the forced response constants, say you are calculating forced response constants. So how do I calculate this forced response constants? So for this, what you have to do is substitute the solution in the original differential equation. So y of t is the solution, right? So now substitute this y of t in this solution, that original differential equation. So what we are going to do is substitute y of t in the linear differential equation. So once you substitute it, you compare LHS and RHS, then you will get the forced response constants. So now how to get the natural response constants? How I am going to get the natural response constants? So this will be more clear once we solve the problem, but I'm giving the steps so that one can follow. Natural response constant, how are going to find? Using the initial condition. As I have said, the natural response is because of the initial condition. So using the initial condition expression, we'll get this natural response constants. So any doubts before we solve one problem on this? Is it clear or
Yes,
clear?
yes.
Okay, someone has mentioned. Sir, I could not understand why we put x of t equal to e to the power po here. Can you write it clear? I'm not understanding. Why we put x of t equal to e to the power. Acha. So,
X of t to the power minus 8 is something like that they are
yeah,
asking.
okay. So, like this is one like exceptional case. Only when x of t is e to the power minus 80, the generalized expression that we have written might not be valid. So that is the only case like where you cannot use this generalized solution. So that's why I have written that exception case. So that is one exception case where the input is that. So only in that case you cannot use this, but other cases you can use. So that's why we have considered that exception case. So Vishnu has asked to revise once. So this week we are going to learn the solution to linear differential equation. So first thing is, why do we need to learn the solution to linear differential equation? Because any RLC network, it is if we try to solve, we'll get a linear differential equation. So how are we going to solve it? So that's why we are learning the solution to linear differential equation. And finally, what is the end? To get the time domain expression, the inductor current or capacitor voltage or capacitor current or inductor voltage. We just want the voltage expression as a function of time. So we want to see how the function is changing. So first we'll start with the first order differential equation, and then eventually we'll go to second order and nth order. So if we have the first order differential equation, I'll just skip each and every step. I'll just explain the overall methodology. So we'll multiply by e to the power 80, and then we'll apply integration on both the sides to get this expression, which has two terms. One is because of the natural response, and one is because of the forced response. Forced response is because of the input, because you can see the input. If the input is zero, then this forced response term vanishes. So that's why it is called forced response, because the input is forcing this response. The other one is the natural response, which is happening due to the initial condition. Because when input is not there, this is happening because of the initial condition, and it happens naturally without the input. So that's why it is called natural response. Now we have applied integration by parts to get the forced response generalized expression. Once we got the generalized expression, then we have written the solution in a generalized form. But we have said that this generalized form has only one exception, when the input is equal to e to the power minus 80. And in that case, the solution is a plus bt or 80 plus b, some constant plus time into some other constant into e to the power minus 80. Then I have mentioned what are the steps you should follow or one should follow to solve the linear differential equation. Once the equation is given, you have to write the generalized solution. And using the generalized solution, how are we going to get the constants? So first we'll solve for the forced response constant, which we'll be getting by substituting this y of t in the original LDE, because this is the solution to that equation. Once you do that, you will get all the forced response constants by comparing the LHS with the RHS, which we'll see by solving a problem. Once we get all k0, k1, k2, etc., then how are we going to get the A expression? We'll get that using the initial condition. So initial condition is used to get the natural response constants. Forced response constant can be obtained by substituting the y of t in the linear differential equation. So let us just quickly solve one problem on the first order thing, and then we'll see. So the first problem, everyone should solve with me. So the problem is dy by dt plus 3y is equals to t, and then y of 0 equals to 1. This is the initial condition. So first of all, can anyone tell me what is the a and what is x of t in this question? So referring to this expression, what is the value of a and what is the value of x of t?
A is 3, X of t is t.
Yes, very good. A is 3 and x of t is equal to t. Yeah, Parvatam x t equal to x of t. Very good. So now let us just copy this and use the same. So this I used to do. So for every question, I'll just keep this aside so that people can know that we are following the same steps and they will be able to correlate. I'll keep this on the side so that first thing I have told is to write the generalized solution. So can someone tell me what is the generalized solution?
So
Sorry.
y of t is equal to some a into
Okay, yeah, just tell me the expression. Y of t is equal to, yeah, give it a try. Even could be
yeah
wrong. Yeah. Capital A
capital A
into
into
e to the power.
e power minus 3t
Okay. Plus now this completes the natural response. Now we are going to
natural
the
response,
forced
forced
response.
response
Hmm.
e power minus 3t integral of t dt.
No, no,
No,
use this
t into I think
expression on the
d,
use this
yeah,
expression on the right hand side.
t
We'll use this
into
generalized k naught into.
yeah k naught into t
Okay.
plus k1 into 1.
Okay.
That's
Then
it.
yes, because now
The
the
derivative
second
of 1 is
derivative,
0.
yes, second
Mm.
derivative and other higher derivatives are zero. So it vanishes after this. So that's why we are only getting two terms. So this is one thing that you should keep in mind. It is actually not infinite series, but it will stop after, like, because it will be only infinite series if it's exponential, but that will come later. How, what if the input is exponential, that we'll see. But if it is some polynomial, after some point of time, the derivative will be zero. So now this completes our first step. Okay, what is our second step?
We need to find the forced response
Force
constants like
response
k naught,
constant.
k1,
Yes, by
k naught and
substituting
k1.
this in the original expression. So one thing you can keep always in mind, whenever we are substituting the solution in the original differential equation, the natural response will always get cancelled. So that you can try, because it is happening naturally. This expression will come when the t equals to 0. When the input is 0, then this is the solution, right? So once you substitute this on the LHS side, this will always get cancelled. So that's how this natural response term is coming when the input is not there. So if you substitute this, it will always get cancelled. So we can directly put this forced response in the original expression and then calculate for the coefficients. It's not that I'm skipping this part. Even if you keep this, it will become zero. So that's why it's not needed. Anyway, it will get cancelled. So that you can try by substituting it, but I'm just skipping it. So now let us just put k naught t plus k1 in this differential equation. So can you solve and tell me what are the expression that we'll be getting once we substitute k naught t plus k1? So basically what I'm doing is I'm substituting this term in this expression. So just tell me what will be the LHS and what will be the RHS. Anyone? D by dt of k naught t plus k1 and 3 into y equal to t. So what will be the expression? Everyone should do, because the difficulty of the problems will only increase. So
Mm.
this is the basic problem. Substitute k naught t plus k1 equal to y in the original expression and tell me what is the LHS, what is the RHS. Like term by term, you
So
can tell
K naught
K naught
plus
plus,
3 K naught into T
yes.
plus 3 K1
Hmm.
is equal to T.
Yes, very good. So now what we'll do is we'll just compare the coefficients. I'll compare K naught, I mean T term with T term, and then the rest with
Yes,
the
yes.
0. So once I do that,
Mhm.
I'll get what is the value of K naught?
1 by 3, I think.
1 by
3 K
3.
naught is equal to,
Yes.
yeah, K naught is 1 by 3.
Now K naught equal to K naught plus 3K1 is equals to 0.
Equal to
So what is
0
the K1 value? K naught by 3 minus K naught by
minus
3.
1. Yes, yes.
Minus 1
Minus
by,
1, I think.
no, K1 is minus K naught by 3.
Yes, yes. Okay. Minus 1 by 9.
Minus 1 by 9. Yes, very good. And I'm telling this because even when I was solving, I have also made many mistakes because of lack of practice. So if I don't practice well, even I'll make mistakes. So you should be thoroughly practicing so that you'll not make any mistakes. So it is completely dependent on math and calculations, and anyone can make mistakes uh, if they don't practice, including myself. So I suggest you to solve as many problems as possible so that you'll not make any mistake in the assignment and the final exam. Okay, so now K naught and K1 are obtained. So first we have got, if you see, forced response constants are obtained. So now let us write the expression. What is the y of t? So now my y of t has become what? Y of t is equals to a into e to the power minus 3t plus K naught t is what? T by 3, and K1 is minus 1 by 9. Agree? This is the solution that we are getting. So first we have solved for the forced response constants. Clear?
Yes, yes.
Okay, so now what is the third step? To get the natural response
Response
constant, which
function.
is A, using what? Initial
Yeah.
condition.
Initial condition y of 0 is 1, I think.
Yes, y of 0 is 1. Very good. So the initial condition is y of 0 equal to 1. So what is the y of 0 expression? A
Plus
plus t equal to
K1
0 you have to put.
plus, plus some K naught
No, no, you have to substitute t equals to 0 in this
is
expression.
equal to 0. Yeah.
Just directly put t
Plus
equals to 0
minus 1
and
by 9.
yes,
Minus
plus
1 by
0
9
minus 1 by 9 equal to 1. So now
equal to
what is the
1.
value of A?
A is equal to 1 plus 1 by 10 by 9.
10 by 9. Very good. So now let us write the final expression. So tell me what is
Y
the
of t
final
is equal
expression?
to 10 by 9 into e power minus 3t
10 by 9 into e to the power minus 3t
plus 1 by 3 into t minus 1 by 9.
plus t by 3 minus 1 by 9.
Minus
Yeah,
1 by 9.
very good. So this is the overall expression. So I have just blindly followed the steps I mentioned and then solved for one by one coefficient after one coefficient. Clear? Any doubts?
No,
Or
no.
maybe I'll repeat once so that others will also be comfortable. So basically what
Yeah.
we are doing is we have one first order differential equation. So we have identified what are A and what are X. So we have written the generalized solution, which is the very first step for any differential equation. So what happens if it's second order? That will go eventually after solving another problem. So first we'll make ourselves comfortable with first order, then we'll move to higher order differential equation. So first I got the generalized expression. So now I have to get constants. One is the forced response constant, which are K naught K1. Other one is the natural response constant, which is A. First, I'll solve for forced response constant, which I'll be getting by substituting this forced response in the original differential equations. Once I do that, I will compare the coefficients of T, coefficients constant, and then I'll solve for K naught and K1. Once I do that, I'll go for solving natural response constant, which I'll be getting by substituting the initial condition, which they have given y of 0 equals to 1. So once I do that, I got A. So I got the entire solution. So I hope it is clear for everyone. Do you have any queries before we go to problem number 2? So now this problem you should be solving before me. Similar problem, slightly bit. So the problem is dy by dt plus 2y equals to 10, and then y of 0 equals to 0. So you start solving it. I'll solve slowly so that everyone will follow, but you start solving it. And keep one thing in mind, there is less than a minute. So this meeting will be closed. Once this meeting is closed, we'll come back again and continue our session. So please do it so that you don't depend on me, but you might make mistakes. Try to not make mistakes, but if you make mistakes, once I am doing, you can cross check and see whether you are making a mistake. So if this meeting ends, kindly join back. So can anyone tell me what is the generalized expression for this solution y of t?
A of t is equal to a into here
Okay.
a into e power minus 2t.
Okay. Okay, so what will be the other term? Anyone? What is the other term? The forced response term? Any guesses? Parvatam or Vishnu? The forced response.
Plus k naught t plus k1.
Sorry, K naught into similar to previous. Yeah, can you tell the expression, Vishnu? Someone was saying, what will be the forced response term? Please give it a try. It could be wrong, but you should try. K naught t plus K1.
K naught
Okay. Okay, but is the x of t same here and there? Here the x of t is t, so
x
that's why
of
we
t is
got
10.
K naught t plus
K
K1.
naught
Here x
into
of
10
t is 10.
K naught into 10 plus k1.
10 plus K1 or so just look at this or
K1
maybe
is 0, yes, yeah. Because of the derivative is 0, yes. So only
so
k
K
naught
naught
will
into
be
10 plus
yeah,
other terms
0.
will be reduced. Okay.
Vanished.
Okay. Okay. Yes. Very good. So someone was asking, so let me just explain it again. So pronouncing what we have discussed is how to solve the linear differential equation. So what we have learned is first we have to get the generalized expression, generalized solution. When the expression is this dy by dt plus ay equal to x of t, if this is the expression, then this is the solution. So first we have to write that solution for any given problem. So once we do that, then we'll start solving the coefficients using this method. So first what we have done is, first we are writing the expression, then we are solving. How to get K1 and K naught coefficient? Yes, so how to get K naught? Forced response constant, we'll substitute the y of t in the linear differential equation. For getting the natural response coefficients, we'll use the initial condition. So first, once we write the expression, we'll get 10 into K naught. So everyone agree, right? Now everyone is clear with this, right? 10 K naught. Yes, very good. Now let us substitute this 10 K naught in the original equation and then solve for the forced response constants. So let us substitute 10 K naught in the original equation. So can someone tell me what will be the LHS and what will be the RHS?
So 0 d by dt of
Okay,
10
0.
k naught is 0 plus 2 into 10 k naught
Okay, so
is equal
2
to
into
10. We will get k
equal
naught as
to
1 by 2.
10. Yes, so K naught is 1 by 2 or zero point 0.5. So now let us write the y of t expression, whatever we are getting. So what will be the y of t expression till now? Y of t is equals to
Into
a
e
into
power
e to the
minus
power minus 2t plus
plus 5. Right? 5.
5. Very good. So now for calculating a, what we'll be using is, we'll be using the
We
initial
have 0.
condition, which is y of 0 equals to 0. So now can someone tell and calculate the value of a?
A is equal to minus 5.
A equal to minus 5. Very good. So now if we write the y of t expression, it will be
Minus 5 e
5
power
into
minus 2
1
plus
minus e
5.
to the power minus 2t. Yeah, very good. So this is how we solve. The method remains
Yeah.
same. for any problem, you just have to follow the method step by step and then solve for one after one another coefficient, and then you will get the final expression. So is this clear for everyone, or someone has queries? Any queries?
No, so far.
Okay. So now we have only learned the first order linear differential equation. So now what happens if we go for the second order differential equation? Yes. So the methodology remains same, the natural response, forced response. But how are we going to get the generalized expression? That is the challenge. So second order differential equation. Okay. Say the d square y by dt square plus a into dy by dt plus b into y is equals to x of t. So now if this is the equation, what we'll do is we'll define some operator as d equal to d by dt. So now what happens is the expression can be simplified as d square plus a into d plus b of y is equals to x of t. So now first, for getting the natural response, we have to find the solution of this d square plus ad plus b. I think someone has not muted. Chandrasekhar, could you please mute yourself? So first we'll solve for the roots of this. Say d square plus ad plus b equals to 0. So like even for first order, you can follow the same, but for second order, we are starting because for first order, we can directly solve. So that's why we have done it. So now first you have to solve this for the roots. I'm sorry. So first you have to solve this for the roots. Once we solve this, say the roots are m1 comma m2. Now what happens is there can be two cases. One is m1 is not equal to m2 and the other case is m1 equal to m2. So first case one, say m1 is equals to m2, or let us go with m1 not equal to m2. Then our generalized solution will be something like this. Y of t is equals to a1 into e to the power m1t plus a2 into e to the power m2t. Okay, and then the rest remains same as what we have learned, which is k naught x plus k1 x dot plus k2 x double dot plus up to so on. So as we have learned, only the natural response will change, the forced response remains the same. Okay, so if we define it, this is the natural response. And this is the forced response. Okay. So like you need to remember this generalized expression. So once we write the generalized expression, then we'll start solving for the coefficients. So this is case one. Now let us go to case two. So what happens in case two? So what happens is, say m1 is equals to m2. Then again, the forced response will remain same. Only the natural response, there will be slight difference. So it becomes y of t equal to at plus b. So which we have learned that exception case. So it will become something like this: at plus b into e to the power. Say this m1 and m2 is equal to
C.
say m. Then we will have e to the power mt plus. Then again the rest remains same: k naught x plus k1 x dot plus k2 x double dot plus up to solve. Okay. So again, this is the natural response. So the only difference is the term that is going to change. And from first order and second order, here we have one more term because it is second order, and forced response remains same for any order. Only the natural response terms will change, and that too they depend upon whether the roots are equal or the roots are different. So any query until this point before we go for nth order. So now we'll generalize for nth order and then we'll start solving problems. Any query, any confusion? No queries? So should we proceed to the nth order differential equation? Everybody?
Yes, sir, you can.
Okay, okay. So now for nth order differential equation. Okay, so someone has mentioned what if the roots are complex? Yes. So what happens if the roots are complex? That is a very good question, which we have not discussed today. So what happens? Okay, let me just add that also. So case 3, which is M1 and M2 are complex. So first of all, if they are complex, there should be complex conjugates because the other coefficients are real, so they can only be complex conjugates. And say they are complex conjugates, then by default, what happens? They are not equal, first of all, because they are not, they can only be equal if they are real. If they are complex, they have to be complex conjugates, then they are not equal because A plus or minus JB, they are not equal. So one thing that happens when M1 and M2 are complex conjugates is what will happen is A1 and A2 will also be complex conjugates because the final result will be real. So A1 and A2 will be complex conjugates. Okay. So now let us solve it. Say M1 equal to A plus IB and M2 is equal to A minus IB. Clear? Now let A1 and A2 also will take some constants. So A1 equal to P plus JQ and A2 equal to
E
P
minus
minus
JQ.
JQ. So now let us solve y of t equal to P plus JQ into e to the power A plus IB into t plus P minus JQ. Sorry, I am using J and I, so let us not use 2, let us use only I, so that there should not be any P plus IQ, P minus IQ. This is also P minus P plus IQ, P minus IQ into e to the power A minus IB into T. So the very first thing that I'm going to do is, first of all, I'll remove e to the power AT outside, okay? I'll take it outside because it's a constant, I mean, common thing in both the things. I'll take it outside. After that, what I will do is, I'll segregate P terms, I'll segregate Q terms. So first, let us segregate P terms. P into e to the power IBT plus e to the power minus IBT. Okay. Then I'll segregate Q terms, which is Q into I read IQ, I'll take common into e to the power IBT minus e to the power minus IBT. So now if you have remember in the complex terms, we know that
Euler's theorem. Euler's
yes. So this will be 2 cos BT
theorem.
and
Which
this
is
will be 2I
minus
sin
2i
B.
sin bt.
So now, like say this is natural, right? Why unnatural? Because we are only solving for the natural response. Forced response, you already know. So now if you solve, we'll get y natural response of t is nothing but 2 into e to the power at. If you solve, you'll get cos dt minus sin bt. So it will turn into cosine and sine. So this is the basic idea. If they are complex. So it will be complex conjugates and eventually they'll become cos or sine. Clear? Whoever has asked? Others also.
Yes, yes.
Okay. So now let us go for nth order differential equation before we solve any further problems. Say nth order differential equation. So in the nth order differential equation, first let us write the expression d to the power n y by dt to the power n plus a1 into d to the power n minus 1 y by dt to the power n minus 1 plus up to so on plus a n minus 1 dy by dt plus an equal to some function x of t. So first again we use the operator and then we'll write it as d to the power n plus a1 d to the power n minus 1 plus up to so on plus a n minus 1 d plus an of y is equals to x of t. So as I have said, first you need to solve for this. Solve and say the roots are m1, m2 up to so on mn. So first thing is case one that we have considered all are distinct, which is the very basic case. So case one, we are
Other
considering
roots.
all roots are distinct. Then we will get any guesses?
Y of t is equal to
Mhm. A1
some
into,
a1 into e power m1t
yes,
plus a2 into e power m2t and so on up to e power mnt.
yes, very good.
An into e power mnt.
So this completes our natural response. Now forced
Natural response
response
and
remains same.
same k naught x plus k1x dash plus k2x double dash and so on.
Yes, very good. So this is our natural response. This is forced response.
Forced responses.
Okay. So now we'll consider another case because we cannot consider all the cases as there are n. There can be multiple number of cases. So another case, simple thing, just to understand how things are going, we'll consider one case where we'll consider like this: m1 equal to m2. So these two roots are equal, and similarly m3 equal to m4 equal to m5. Okay, so in this case, what will be the case? So if you go back here, what we'll be getting when m1 and m2 are equal, we'll get at plus b into e to the power m1t, right? Both
Yes, yes.
terms will be combined and we have one coefficient, a polynomial of t. So in the case of m1 and m2, we'll have what? At, say a1 t plus b1
B
into e to the power m1t.
let us take this as m1 n2 is for some other one, then
Okay,
we can take
then okay, that's also okay. So what we'll do is we'll consider this as some m, and then we'll consider this as
n.
m dash. Right.
So,
So now this will
so
become e to the power
e power mt.
mt. So now three terms are there. So for two terms we'll get t. For
Yeah,
three terms we'll get
t
t
square.
square. So any guesses?
A2 t square
Yes.
plus b1 b2 t
Hmm.
plus c2
Okay, very good. Into e to the
to
power
e power m dash t.
m dash t. Yes. So from
This is
m6 we
not
have as it is.
yeah.
So we have a6 e to the power m6t plus up to so on an e to the power m n t, and then
plus
the
forced response k naught x plus k1 x dash.
plus up to so on.
We get variable dashes.
Okay. So now this is our natural response. So only we just have were learning directly how to write the solution. So after writing the solution, then we are solving for the coefficients. Forced response. Clear everyone, or any queries, any doubts? Is this clear?
Yes, yes, sir.
Okay.
It is clear.
Others,
Some.
everyone
Yes, yes, clear.
clear. Okay. Okay, we'll start with this problem. So now they are not going to give you the differential equation. So when we are solving these problems, one thing you have to keep in mind, no one is going to give you the differential equation. First, you have to write the differential equation for the question. And then after getting the differential equation, then we have to solve for the differential equation and then get the expression, and then you substitute the coefficient. So as you see, it's first of all lengthy problem. And second of all, it is completely dependent on the math. So any single step you make mistake, you will deviate from the answer and you will lose all the 6 question marks. So these will be again passage questions, because it is a lengthy question. So they have like so many problems that are linked to this problem. So you have to do it perfectly. That's why I'm telling again and again, you have to solve as many problems as possible, because even I am making many mistakes because I have not practiced, right? I will only solve those problems which I'm solving here. So practice is very much crucial, and you have to practice. Then only you'll not make mistakes in the final assignment as well as exam. So now let us take this screenshot. So now we are going to the problem solving session, and this will be our problem 3. So someone mic is on. Can you please turn it off? Thank you. So this is our first question. So first, let us see what they are saying. First, they said the switch is closed at t equals to 0. So before t equals to 0, only the inductor as well as the resistor and the voltage source are in series. And they're saying before that, the above circuit was in steady state and capacitor was uncharged. So can you tell me at t equals to 0, before the switch is closed, what will be the value of I of t and what will be the value of V of t? So initially, voltage, inductor, and resistors are in series, and then they have reached steady state, and then capacitor is initially uncharged. So the capacitor value is 0. So what will be the I of 0 minus before the switch was closed? What will be the current that is flowing through inductor? Anyone?
Is L into dA by dt.
No, it has
Sorry.
reached steady state. So let me draw the circuit. So I have told you at steady state how the inductor will become short circuit or open circuit. So this is the initial circuit. So 4.5 amperes, Vishnu, very correct. So it is 180 by 40, right? So at steady state, inductor will become short. So this is 180 volt and this is 40 ohm. So from there, what are we getting? What is I of 0 minus IL of, sorry, I of 0 minus 180 by 40 is how much? 4.5, right?
Yes.
And then similarly, V of 0 minus is how much? 0, because initially they said uncharged. So these are the initial condition which we'll use to solve for the natural response coefficients. So before we solve, first we have to get the differential equation. So let us draw the circuit and then let us get the differential equation. So everyone should do with me, along with me, or you can go ahead and then Once I do, you can cross check. Okay, so the values are plus minus 180 volt, 44 Henry. This they are calling I1 of t, sorry, I of t, I of t. And then this I'll call IC of t. And then this I'll call IR of t. And R is 40 ohm. And this is 1 by 440 farad. And then this they are calling V of t. Okay, before we proceed further, can someone tell me what is IC of t in terms of V of t and what is IR of t in terms of V of t? I need these two expressions.
IR of t is equal to 180 by 40.
IR of t equal to
180 by 40. V
y?
by R. 40.
Why 180 by 40?
Yeah, actually, we have R L also. So.
Sorry. So you have to realize that this case is when switch is not closed. Before switch was not closed, this was already in steady state. Now at t equals to 0, switch is closed. So now the inductor dynamics will be there, capacitor dynamics also will be there. So you cannot consider inductor to be open circuit or short circuit. Similarly, capacitor, we cannot consider open or short circuit because now we are dealing with the inductor. Inductor and capacitor dynamics will come. Clear? So can someone tell me what is IR of t in terms of V of t and what is IC of t in terms of V of t? No, I don't want it in terms of I of t or IC of t. I need in terms of V of t. So this is V of t, which is the voltage across capacitor. I need IR of t. I need IC of t in terms of V of t. So V of t is the voltage across capacitor. So I need IR of t in terms of V of t and IC of t in terms of V of t. Any guesses? Anyone? It is very straightforward.
IR of t equals to V of t minus 180 by 40.
Uh,
Yes,
V of t
yes.
minus 180. What is the voltage across the
VL of,
resistor?
this VL of
V of,
t minus
of t by
180 by 40.
V of t
So
by 40. That's it.
yes, V of t by 40 because the voltage across the resistor is directly V of t.
Oh,
Okay. So this is one expression. Okay. Now, what is IC of t? You have to use the IV relationship of a capacitor. That is the hint I am giving.
1 by C, I mean 440 integral of
Okay, first tell I
1
in terms of C and dVC by dt. What is the expression?
is equal to 1 by C integral of dV by dt. C into dV by dt equal to
C into dV by dt, right? Now tell the expression in terms of these values.
440.
You are saying C and then now you are saying 440. Is it 440 or 1 by 440?
Yeah, yeah, 1 by 440.
Okay, 1 by 440. And then dV by
dV by
dV
dt.
by dt. Yeah, very good. dV of t by dt. Okay. So now what I will do is I'll calculate I of t. So I of t is nothing but IR of t plus IC of t, right? Using KCL.
Yeah.
So now once we do that, I'll get V of t by 40 plus 1 by 440 into dV of t by dt. Clear? Until this
Yes,
step?
yes, yes.
Okay. So now what I'm going to do is I will apply KVL in this loop, okay, in this direction. So now let this voltage be VL of t, and the voltage across the resistor is V of t. So now tell me what will be the expression for KVL in terms of 180, VL of t and V of t.
So 180
Okay,
minus VL of t
okay,
minus V of t is equal to 0.
yes, very good. So now let us take this to RHS side. So I will get 180 equal to VL of t plus V of t, right? Right?
Yes, yes.
So now what is voltage of an inductor in terms of inductance and its current?
L into di by dt.
Yes, very good. So L is how
I
much?
mean, what is-
44, right?
yes,
44 into di of t
d
by
by
dt
dt.
plus V of t. So now what basically we will do is we will substitute this I of t in this expression.
Okay.
So let us substitute it and write the expression. So what we'll be getting?
So 180 is equal to 44 into.
Okay, so I'll just write the simplified expression. You just check whether it is correct or not. So we have 1 by 10 into d square v by dt square plus 44 by 10. So it is 11 by 10 into dv by dt plus v equal to 180. Everyone agree? Or am I making any mistake?
So 1 by 10 into d square v by dt square plus 11 by 10 into dv of t by dt plus v of t is equal to 1. Yes, right, sir.
Very good. Okay. So now let us take multiply by 10 on the both sides and then write the simplified expression.
v of t by dt square plus 11 dv of t by dt plus 10 into v of t is equal to 1800.
Okay. So first, what is the okay? Now we got the uh, expression. So what we got is now we got the differential equation. So now we have to solve for this. So what is the first step? First step is to write the generalized solution for this, right? But before writing the generalized solution, we have discussed that we have to calculate the solution of something, right? To calculate the roots. So what is the equation to which we are supposed to find the roots and what are the roots?
D square plus 11d plus 10. We have to find the roots for this
Yes, very
equation.
good. D square plus 11d plus 10 equals to 0.
10
I hope everyone else is also following. If you have any queries, please stop. So what are the roots M1 and M2?
d plus 10 plus 1 d minus 10 and minus 1.
Yes, minus 10 and minus 1. Others are following, right? I am only hearing from one person. Minus 1 and minus 10, right?
Y of t is equal to
Correct?
a1 into e power minus 10t
Okay,
plus
now what
a2
will be the generalized solution? Others, can anyone tell me?
a1 into e power minus 10t plus a2 into e power minus t.
Yes, A2
This is
into
the
e power
natural
minus t
response
plus,
plus
yes,
k naught into x
which
plus
is
k1
what?
into
Okay, what is
yeah,
x
k
here?
190 I think.
1800, right?
1800, yes, 1800.
So we'll have only 1800 K naught, right?
Yes.
Other terms will vanish because it is constant. Okay. So now we'll have to solve for A1, A2, and K naught. But before we do that, okay, let us go back and see. So how are we going to do that? So how are we going to do that? We know that once we get the solution, we have to get the force constant by substituting y of t in the linear differential equation, and then for natural response coefficients, constants, we have to get the initial condition equation. So let us solve it. But before we solve, I just want to check others are following. Karthik and Parvatam, Pranav Singh, Vishnu, are you able to follow? Or you have any queries before we proceed further? Because Now we are getting into the flow. If you have queries, you ask before we. Karthik, please erase it. Whatever you have drawn. Okay. Clear, sir. Okay. Parvatam, you have a query. Can you please ask your query? I cannot hear you if you are talking. Parvatam, can you please ask your query? What is your query? I'm not able to hear you if you are talking. If you are unable, if you have mic issues. Okay. How did you get di of t? Okay. So this is I of t, right? So I of t is v of t by 40 plus 1 by 440 dv of t by dt. Now I have to differentiate with respect to time. So this term will become 1 by 40 into dv of t by dt, and then this will become d square v of t by dt. So basically what we are doing is d by dt of v of t is what? And then d by dt of dv of t by dt is what? So this will be dv of t by dt, and then this will be d square v of t by dt square. So this is how we are getting. So Karthik, I think you are by mistakenly drawing. Just please don't do it again. So is this clear? Now is this clear how we are getting? So we have differentiated it with respect to time, and then we got this expression. Yes, sir. Okay. So now first what we'll do is first we are going to substitute this 1800 k naught in the above expression to solve for k naught. So can anyone substitute 1800 k naught in the above expression and tell me
K
what
naught
is
is
the
equal to 1 by 10.
k naught equal to
1 by 10.
1 by 10. Very good. So what we'll be getting is we'll get 10 into 1800 k naught equal to 1800. So now once we do that, we'll get k naught equal to 1 by 10. So once we do that, what will be the value of y of t?
A1 e power minus 10t plus A2 e power minus t plus 180.
Minus 10t plus a2 into e to the power minus t plus 180. Basically, y of t is nothing but here v of t, right? Because we are getting in terms of v, I have written y, or maybe let us write it v to avoid any further confusion. So this is my v of t. V of t, this also is my v of t. Okay. So now we know that initial condition of v of t is 0, right? V of 0 equals to 0, right? Agree, everyone? V of 0 is 0, right? From here.
Yes.
So now after substituting it, what is the expression that we are going to get?
A1 plus A2 is equal to 0.
0 or
Minus 180.
minus 180. Yes, very good. So we will get a1 plus a2 equal to minus 180. Okay, so now I got one equation, but there are two unknowns. So what to do? First of all, there is less than a minute, so this meeting might end soon. So if it ends, kindly join back so we can continue our discussion. Okay, now coming back to our question, we have two equations, but we got only, sorry, two unknowns, but we have only one equation. So how to solve? Let us go back to the question. The hint is on the screen. So
I of 0 is equal to.
yes, very good. So I of 0 minus is what? 4.5 amperes. So now what we have to do is we have to calculate I of 0. So now I know V of t. So how to calculate I of t? I have the expression. I of t is this. So let us substitute V of t in I of t and then solve. This meeting might end. Please join back. Okay, this is my V of t. Now I have to calculate I of t. Okay. And then use this another initial condition to solve for AB or A1, A2 here. So these are the three equations. So first, let us solve for I of t. Can anyone tell me what is the expression of I of t? So let us take e to the power minus 10t common. You will get what? A1 by 40 minus 10 A1 by 440, right? Agree? I'm just substituting it. Everyone? Hello?
Yes, sir. Yes, sir.
Yeah. And then e to the power minus t, what will be the coefficient?
A2 by 40
Okay. Minus
minus 2 by 440 into 440.
minus A2 by 440, right? And then we have this 1800 K naught.
A not.
1800 K naught, now it has become 180, right?
Yes, sir.
By 40, because V of t by 40. Or maybe I'll directly write this 180. So 180 by 40. Clear? So this is the expression 180. Any doubts? Or you have any doubts? We are just substituting V of t in the other expression and then we are just getting the expression. So let us just quickly simplify this. So we have I of t is equals to, this will be, if I multiply by 11 by 11, so you will have A1 by 440 into e to the power minus 10t. Then if we multiply by 11, 11, we have 10. So 10 by 440 is, so let it be 10 by 440. 10 A2 by 440 into e to the power minus t plus this is 4.5. Again, if you see, this is our first two terms are natural response. This is our forced response. Clear, everyone? Any doubts you have? I'm just substituting it and I'm writing the final expression. Clear, or any queries you have?
Yes, sir. Yes, sir. Yes, sir.
Clear. So now let us use the initial condition. I of 0 is 4.5 amperes. So once you substitute I of 0 and then equal to 4.5 amperes, can you tell me what is the relation that you will be getting in terms of A1 and A2? Substitute t equals to 0 and then substitute
A1 by 440 plus 10 A2 by 440 is equal to plus 4.5.
equal to
Is equal
4.5.
is equal to 4.5. 4.5 gets cancelled on both
Cancel.
sides.
Yes.
So we'll get A1 plus 10 A2 is equal to 440.
Equal to 0 because on the RHS side you have 0.
Yeah, 0. Yes, 0.
Okay, so this is one equation, A1 plus A2 equal to 0 and then A1 plus A2 equal to minus 180. So A1 plus 10A2, then A1 plus A2 equal to minus 180. Now can you solve for A1 and A2? Everyone.
So A2 is equal to 20.
Okay.
A1 is equal to 200, I think.
A1 equal to
200. I think so.
minus 200, right? Because
Yeah,
A1
minus
plus
200.
A2 is
Yeah,
minus
minus
180. A2 is
yes, yes.
plus 20.
20.
Okay. So now, okay,
V of
very
t.
good. So now what is V of t?
V of t is equal to minus 200 e power minus 10t
V of t
plus
equal to
20 e power minus t plus 180.
minus 10t plus 20 e to the power minus t plus
E
180.
plus 180. I of t is equal to
A1 by 440, which is minus 200 by 440.
yeah. So this
I see only one person doing. What about others? Sir, how
minus
A1 plus 10 A2 equal to 0? Please explain. So, I of 0 is 4.5 amperes, right? So, first substitute t equals to 0. So on the LHS, you have I of 0, which is 4.5, which gets cancelled with 4.5. Now, because T you have put 0, this term will become 1 and this term will become 1. On the LHS side, you have 0. So A1 plus 10A2 by 440 is equals to 0. So if I take 440 that side, I have A1 plus 10A2 equal to 0. So basically, I have used this expression and then I got this expression. Is that clear now, Pranav? Yes, sir. Okay. So now let me know the expression for I of t. I of
Yes,
t is
minus
this minus.
5 by 11 e power minus 10t.
Okay, so if we simplify, you'll get minus 4545 e to the power minus 20 and then plus 0.4545
E power minus
minus
t
t and then
4.5.
4. Okay, very good. So now we have reached the final solution.
Compare
So now
the
we have to compare what are they asking versus what we have
AI
got.
is equal to minus 5 by 11.
So let us go back here and then say first I of t coefficient is AI. Okay,
AI
so
is equal to 4.5.
okay, so let us write this first here. They're asking AI and then probably BI and then CI. Okay, so AI they're asking, then BI
4.5.
and then CI, and then they're asking AV, BV, and then CV. So first we have to be very careful whether BI is e to the power minus t or e to the power minus 10t. So it is minus t. Okay, so AI is 4.5
Minus 4.
and then minus t is 0.4545 and this is minus
Minus 0.45.
0.4545. Similarly here this is 180, this is 20, this is minus
Minus 2.
200. Okay, let us compare. So AI is 4.5. So AI is 4.5 in the range and BI we got 0.4545, which is also in the range. CI you got minus 0.4545, so which is also in the range. AV you got 180, BV you got 20 and CV you got minus 200. So you have to be very careful. You have to enter the minus sign also and then you have to be careful and see whether you are getting the correct answer or not. So let me just summarize. Once I summarize, if you have any doubts, you can ask. So in this question, they are asking what is the I of t value, what is the V of t value. But the very important thing is before they have closed the switch, the circuit is already in the steady state, which means at t equals to 0 minus, inductor is shorted, and I got the one initial condition I of 0 minus, which is 4.5 amperes, and V of 0 minus, which is 0 because they have said capacitor is initially not charged. Then once I have got the circuit, first I have calculated IR of t and then I have calculated IEC of t, using which I have calculated I of t. Then I have applied KVL here and then I got the differential equation. So the very first thing, important thing in any question is to get the differential equation. Once you get the differential equation, you know, first you have to solve for the roots. Once you get the roots, you get the natural response and you get the forced response from this 1800. Once you get that, first you have to calculate K naught by substituting this in the original equation. So I got K naught. Now for calculating this A1 and A2, you have to use initial condition. So one initial condition is from V of t, what expression you got, another initial condition you got from I of t. So two initial conditions, two equations, two unknowns we have solved. Once we got, then we have substituted to get I of t and V of t. So now I can calculate any expression. Say they asked what is IR of t, you know IR of t is V of t by 40. Similarly, if they ask IC of t, you know it is 1 by 440 dV of t by dt. So first you have to calculate one solution. Now using that solution, you can get any other expression. So is that clear, everyone? Or you still have any queries before we proceed to the other problem? Okay, so we have around half an hour left. So now this is like first order. If you see, looking at the circuit, you can tell what is the order. If it has like you have to count the number of inductors and capacitors. So here it is two, right? Inductor and capacitor. So it is second order. And here it is one. So that's why it is first order. So very simple because they are only corresponding to like either they'll give one derivative or one integral, right? Resistor, it is just a direct quotient. So if you see, the entire problem took a lot of time, but once we got the solution, we have solved like 6 problems at a time, right? 6 problems are six like marks, or maybe 6 questions are related to these 2 lines. But in order to get these 2 lines, you have to do all these calculations. So if you make any mistake at any point of time, you will lose marks. So you have to be very, very careful. I'm telling this again and again. Okay. So this is our next problem, problem 4. Although it looked like problem 4, but we have solved like 6 questions in the previous problem. Okay. So the circuit was in the steady state before the switch was closed. So what is I1 of 0 minus value? I1 of 0 minus. Okay, or let me draw the circuit. So inductor will be shorted or what? At t equal to 0 minus before.
I1 of 0 minus is 1 ampere.
1 ampere, because this will be shorted. So
Okay, yeah, 12 by
one
12,
initial
1 ampere.
condition, I1 of 0 minus equal to 1 ampere. And I2 of 0 minus?
So it is 0.
0. Yes. Very good. So we have uh, so like this is kind of a hack. You can realize, say what I will do is I will substitute okay, let it be there. Like I'll not tell, then you will try to uh, do. So like what I was trying to say is, if you put t equals to 0, then you will get a1 plus b1 is equals to 1, and then a2 plus b2 equals to 0. So like directly you are getting 2 equations. Say you have like gotten only one of the constant, then you can use these expressions to get the other constant, like easily simplified. Rather than using the original solution and substituting it there, from here only you got 2 equations, right? You can also use these 2 equations to solve rather than using the original equation. If you are running out of time and you have to quickly get it, then you can use these 2 expressions. And yeah, but I don't recommend this. You just solve and then substitute it, and then you can check whether I of 0 is 1 ampere or not. But if not, you can also use this. Okay. So now once the circuit is closed, let us draw the circuit. 2 Henry. Okay. So this is plus minus. Sir, can you discuss the solution once if x of t is constant, if x of t is exponential, if x of t is t in first order circuit? Okay. So if x of t is, say, not exponential, if x of t is just constant or polynomial, then you can directly use this expression like a into t to the power minus at plus k naught x plus. So it's the sequence of the derivatives of the x. X could be any polynomial, t square plus 3t plus 4, or function of t, not exponential. Then this is some like what, a into e to the power n minus at, which you are getting from the natural response. This you are getting from the forced response. Only when x of t is e to the power minus at, then you have this exceptional case. But what happens if x of t is exponential? That is not covered in this week. That will be coming in the next week. So next week, what we'll be discussing is for a sinusoidal excitation. So sine, I can write as summation of 2 exponential, right? E to the power say sin omega t is e to the power j omega t minus e to the power minus j omega t by 2j, or cos omega t is e to the power j omega t plus e to the power minus j omega t by 2. So this will be covered in the next week. So let us not go into the exponential excitation this week as of now, because anyway it is not there in the assignment. And if we cover that, we'll lose time to solve one more problem, which I want to avoid. So next week we'll do. So if it has exponential, it is a little bit simpler, but it is also very good, like interesting once we discuss next week. So let us go back to our problem. So this is 2 Henry. This is 2 Henry. This is 12 volt. This is 12 ohm. And this is 8 ohm. So basically, instead of before calculating I1 of t or I2 of t, let us assume this as I of t. Okay. And then as both are parallel, what is the parallel of 12 and 8 ohm? Anyone? What will be the parallel of 12 and 8 ohm? Anyone?
Is 24 by 4.8.
4.8. Everyone agree? Okay. So now let this be I of t and this will be VL of t. So again, we are doing the same thing. We are applying KVL in this equation. So what will be the expression, anyone?
So 12
Okay.
minus 2 into
Okay.
dVL of t by dt.
Okay. Or let us write in terms of VL of t currently. Let us not write that expression. Tell in terms of VL of t. 12 minus. Okay.
12
Let
minus of t,
VL of t. Okay.
uh,
Minus.
minus 4.8 into I of t.
Okay. Equal to 0. So now let us substitute VL of t. What is VL of t?
2 into di by dt.
Okay. Very good. 2 into di by dt plus 4.8 into I of t, right? So now let us divide it by 2 for our ease. So we'll have di by dt plus 2.4. This is I of t. This is also I of t equal to
Is equal to 6.
6, right? So now this is our equation that we got. So can anyone tell me what is the generalized expression of this?
So d plus 2.4
So
into
I
I
of
of
t
t is
equal
equal.
to first the general natural
So
response
e into e power
minus.
minus 2.4 t
Okay. Now
plus
the force
k1
response.
into 6. Sorry, k0 into 6.
Okay. Or 6 cannot.
Yes,
So
that
this
is
is the generalized solution that we are getting. Now we'll solve for A. Before that, we'll solve for K naught. So how do I get K naught? By substituting this in this expression, right?
yes. So
Yes. So let us substitute it. What we'll be getting? 2.4 into.
k0 into 6 is equal to 6. So k0 is equal to 1.1 by 2.4
Okay. What is the value?
is 0.41.
Okay. Others agree because I'm not calculating it. Can others say K naught is 1 by 2.4? So
Yes,
0.416.
yes.
Okay, good. So K naught is 0.416, right? Okay. So now let us write the resultant I of t. What is I of t now? A into e to the power minus 2.4t plus 6 k naught. So k naught is already 1 by 2.4. 6 k naught is what? 1 by zero point 0.4. So what is the value of 1 by 0.4?
10 by 4, 2.2,
2.5.
2.5. Yes.
Okay. So this is the expression that we got. So now how to calculate A?
So
How to
substitute
calculate?
if t is equal to 0.
Yes. I of 0 is 1 ampere, right?
So, yes. So
So
1 is
now can
equal to
calculate
a,
A.
plus 2. A is equal to minus 1.5.
Very good. So now we'll get I of t, right? So let us write the final expression. I of t equal to
Minus
2.5
1.5 0.4t plus 2.
e to the power minus 2.4 T. Okay. So in the question they are asking what? They are asking what is the value of I1
I1
as
of
well as
t
they will
equal
ask what is the value of
current
I2.
is
So
values of
let us write what is I1 and then what is I2. So this is I of t. So here we have I1 of t. Here we have I2 of t. So what is the relation between I1 of t, I2 of t, I of t? Because they are asking I1, I2, and
I
like
of
how?
t is equal to I1 of t plus I2 of t from KCL.
Okay, or yeah, that is one way. Now I'm asking what is the value of I1 of t in terms of I of t as well as I2 of t in terms of I of t. Because I have calculated I of t, now I want to write everything in terms of I of t so that I can like you use it so that I can directly get the expression of I1 of t as well as I2 of t.
So I1 of t is equal to I of t into 8 by 20.
Yes, very good.
That is
Yes, use current
0.2
division. Vishnu also said.
0.4 into I1 I of t.
Okay, very good. So I1 of t is equals to 8 by 20 into I of t,
I of
which is zero point 0.4 I of t. Now, similarly, I2 of t is equals to 12 by 20 into I of t, which is zero point
3
0.6
by 5.
into I of t.
0.
Yes. So now can you tell the expression for I of t and I2 of t?
I1 of t is minus 0.6 e power 2.4 minus 2.4 t
I1 of t equal to 1
minus
minus
0. Or
e to the
1
power.
minus 0.6 e power minus 2.4 t.
Okay. And I2 of t.
Right of t is 2.5 into 1.5
Okay.
minus
Hmm.
0.9 e power
Hmm.
minus 2.4 t.
Okay. So I hope everyone is getting the same expression. Vishnu, are you also getting the same expression? Okay, so if we go back here, they're asking A1 plus B1, A2 plus B2. So let us see what is A1, what is A2, what is B1, what is B2.
A1 is equal to 1, B1 is equal to minus 0.6,
So A1 is 1
equal to 2.
minus
B1 is
0.6.
1 minus 0.6,
Okay,
K1 is equal to 2.4.
fine, right?
A2 is 1.5, B2 is minus 0.9, K2 is also 2.4.
Okay. So now K1, K2, right? I forgot this.
Both are
So
2.4.
both are 2.4. So I can write K1 equals to K2 equals to what? Minus 2.4. Okay. Okay. So now let us go and check. So A1 is 1. So A1 is 1. And then A2 we got minus 0.6. So it is in the range. K1 is 2.4. It is in the range. A2 is what? 1.5. It is in the range. And minus zero point 0.9, minus zero point 0.9. And then K2 is also 2.4. So again, if you see, there are 6 questions that are related to this problem itself. So if you make any mistake, you lose marks. So I'm telling this again and again because it is very important. So let me just summarize what we have done in this problem. So in this problem, it is first order, so it is much simpler than our earlier problem, which was second order. So in this, what we have done is we have checked what is I of 0. I of 0 is 1 ampere and I of 0 minus. And like one thing that I would like to tell is initially at t equals to 0 minus, just at once the switch is closed. So this is one important thing that you should take note. I have just made small mistake. So at t equals to 0, we have closed the switch, right? So what happens is the inductor is already shorted just at that event because inductor cannot current cannot change, right? And then this is the scenario, right? Just at t equals to 0. So we know that this current is how much? 1 ampere, right? Agree? At t equals to 0. inductor current just after closing the switch.
Yes, sir.
Yes. Now, what is I1 of t and what is I2 of t? So this is the event at t equals to 0 plus before, not before closing the switch, after closing the switch. So now what is the value of I1 of t or I1 of 0 plus and I2 of 0 plus? It's a resistive dividing thing, right? Just after 0, t equals to 0 plus. So it's a resistive divider, right? You just do it and tell me.
I1 0.4, I2 0.6.
Okay. This is 0.4. This is 0.6. Okay. So now if you see, before connecting the like switch, it has zero current, but just after connecting it, it current got changed from 0 to 0.6. So this is 0 minus. You have to be very careful. This is 0 minus. And then this is 0 plus. So before closing the switch, the current is 0. But once the switch is closed, then we are calculating the I1 of t, I2 of t, right? So that's why they are saying this t greater than or equals to 0, not t less than 0. So after the switch was closed, so for t greater than or equals to 0, we are calculating the currents I1 of t, I2 of t. So now if you substitute t equals to 0, then I1 of 0 should be 0.4, I2 of 0 should be 0.6, not 0. Right. So this is the mistake I have mentioned. So these are before 0 minus. So A1 plus B1 will be 0.4 and A2 plus B2 will be 0.6, not 1 and 0, because these are before the switch was closed, not after the switch is closed. And they're asking after the switch is closed. So this was one mistake I have mentioned. So it is not 1 and 0. So let us go and check. What is A1 plus B1? It is 0.4, right? And A2 plus B2, it is 0.6. So these are after the switch is closed, but before the switch was closed they are having a different values. After the switch is closed they are having different values. Because it's a resistor, the inductor current, the current through the resistor can change drastically. Also the voltage can change drastically, but for inductor current, the current for the inductor, the current cannot change drastically. So before t equals to 0, after t equals to 0, it also is 1 ampere. Only the currents in the resistors are changing accordingly. Got it? Is this clear? So that you will not make this mistake. So A1 plus B1 is 0.4, A2 plus B2 is 0.6. Get it? Clear? Please repeat. Okay, I'll repeat. So A1 plus B1 equal to 0.4 and A2 plus B2 equal to 0.6. Okay. So what I was trying to say is before the switch is closed. So before the switch was closed, what happened? The current is 1 ampere. So I1 of 0 minus. So this is when t is less than 0. So this is t equal to 0 minus. So before the switch was closed, then the current through the resistor is 1 ampere and the current through the other resistor is 0 amperes. Once the switch is closed, what happened? The inductor current cannot change drastically. So it will still be 1 ampere. Now the current through both the resistors summation will be 1 ampere. I1 plus I2 will be 1 ampere. So from this resistive divider circuit, I know that I1 of 0 plus, because this is after closing the switch, which is 0 plus. So I1 of 0 plus is 0.4. I2 of 0 plus is 0.6 from the resistive divider circuit. So I1 of 0 plus is 0.4, meaning if you substitute t equals to 0, you will have A1 plus B1 is 0.4, A2 plus B2 equal to 0.6. In the question, they have asked the solution for t greater than 0, which means the at t equals to 0, the I1 of 0 value will be 0.4 and 0.6, not 1 and 0. This is before closing the switch. So at t equal to 0 minus and at t equal to 0 plus, both the resistor are having two different values of the current. So the current in the resistor is not continuous and it can be discontinuous. Whereas the current in the inductor has to be continuous, because if it is discontinuous, then the derivative of the discontinuation function will be infinite. So the voltage will be infinite. So that cannot happen. So that's why I'm telling that you have to be careful. These are before the switch was closed and this is after the switch is closed. So one have to be very careful. And here, while taking the initial condition, I have taken for I of t. I of t is continuous. So I of t is 1 ampere after the switch is closed, before the switch is also closed. So I of t is continuous. So I am using that initial condition. Whereas the resistor current, there is step. So you have to be very careful, because after t equal to 0, they have different values. Before t equal to 0, they have different values. So you have to be very careful and clear. Understood, right? So this is the one thing that I have told that a1 plus b1 equal to 1 and a2 plus b2 equal to 0 at the beginning. So I am correcting myself. So a1 plus b1 will be 0.4, because this is for t greater than 0, and t greater than 0, I of 0 is 0.4, and t greater than 0, I2 of 0 is 0.6. So a1 plus b1 is 0.4, which you are getting from here, and a2 plus b2 is also 0.6, which you are getting from here. So in this problem, like a simple problem, but that is tricky thing. So they can ask, what is I1 of 0 minus and what is I1 of 0 plus? What is I2 of 0 minus and what is I2 of 0 plus? So one should be very clear about this concept. They are not same, they are different. So they can, this type of questions can be asked in the exam. The problem is same, but the question that they have not asked in the assignment, they can ask in the exam. The problem is still the same. So this is very like conceptual question and one can make mistakes. So I hope it is clear now. So any problem, the methodology is same. First get the differential equation, first write the generalized solution. After getting the generalized solution, substitute the fixed forced response in the original differential equation, get the forced response constants. Once you get that, use the initial condition to get the natural response constants. Once you get that, you got the expression. Now using this, you calculate whatever they have asked. So first you have to get one fixed solution, like I of t or b of t. First you have to get one. Using that, you can derive the other ones. Like here I got I of t, from there I got I1 of t, I2 of t. But I was not trying to solve I1 of t or I2 of t. Maybe it is easier to solve I1 of t, but if you see, I have combined these two. So there is no I1 of t, I2 of t in this circuit. So that's why I have solved for I of t. But if I have to solve everything in I1 of t, then I have to convert I of t into I1 of t, I2 of t into I of t, I1 of t. It makes things a little bit complicated. So first solve the circuit. Once you get one expression, then using that you calculate the other, rather than trying to convert everything into this I1 and I2, which is also okay, but makes things complicated a little bit. So any queries until this point?
No, sir, no.
Okay, so today we have discussed about the linear differential equation solution for polynomial input or any constant input. But what if it's exponential or sinusoidal? That will be covered in the next week. So today we have started with the first order linear differential equation and obtained its solution. And then once we have understood the concept, we have seen also one exception, which we have not solved any problem today. Probably next week we'll solve, because this is exponential input. So that's why we have not solved today. And then we have generalized the steps to solve the linear differential equation, writing the generalized solution and then getting the forced response constant followed by the natural response constant. Then we have solved two problems to understand the concept and to learn how to apply the learned concept in problems. Then we have gone to second order differential equation. We have seen three case studies, and then nth order differential equation. Although in the exam it will not go above second order, but one should have the knowledge of how to solve the nth order differential equation. So we have covered this aspect also. Then we have seen one problem which is a second order, because it has one inductor and one capacitor. So total two energy storing elements. So it's second order. So any problem, first you have to get the differential equation, then solve for the roots, write the natural response, forced response, calculate the forced response constant by substituting this in the differential equation. Once you get the forced response constant using initial condition. So here there are two unknowns in the natural response. So you have to use two initial conditions. So these are the two initial conditions using which I got two equations. Solving that, I got the coefficients, then I got the expression. In the next problem, it is first order. So first order differential equation followed by the solution, followed by calculating K naught, followed by calculating A using the initial condition. So once I got I of t, I have calculated I1 of t, I2 of t, which are fractional scalar multiplication of I of t. So once I got that, I have cross-checked and everything is matching. So I think we have checked, right? Uh, I don't know whether we have checked. So this is 1 and this is minus 0.6. This is 2.5, right? If I'm not wrong. Sorry, 2.42, right? 2.4 minus 2.4. So K1 is not minus 2.4. K1 and K2 are 2.4. So this is plus because they have already given minus. So this is plus 2.4. And B1 is minus 0.6. And then this is A2 is what? 1.5. And this is minus 0.9. And K2 is also 2.4. So any queries or is it clear? Everyone? Clear, sir. Okay. So
Yes, sir.
I always request you to, I again request you to solve as many problems as possible because one mistake can cost you 6 questions, 6 marks or more than 6 marks. So it is very, very important and also very critical to solve as many problems as possible so that you will not make any mistake as it is purely mathematical. Only you have to get the equation and solve step by step and solve for the coefficients and constants. Okay, I wish you all the best for your assignment. Do well in the assignment, solve as many problems as possible. We'll meet again in the next week with the solution to linear differential equation with sinusoidal excitation. Okay then, good night and I wish you all the best for your assignment. If you have any queries, you can reach out to me. I'll try to help. Okay, see you in
Thank
the
you, sir.
next
Thank
week. Good night. Yeah, thank you.
you. Good night.
Good night. Good night.